here there are four factors which influences the season. That is the spherical shape of the earth and the curvature of its surface. This, and there is daily rotation of the earth on its own axis. Then the tilt of the axis of rotation when compared to the plane on which the earth moves. This is third factor. And fourth is it is the earth's movement around the sun in a year. These are the four factors which influences the seasons. So we have discussed the first one, curvature of the earth. What is meant by curvature of the earth? I am giving the gist points which we discussed already. It is the shape, spherical shape of the earth. Instead, curvature shape of the earth. It means spherical shape of the earth. Understand? Look at dear students here. How is the shape of the earth? It is spherical shape. Understand? This spherical shape of the earth causes the heat to distribute on earth's surface differently, right? Because look at here, this is the equator. So on equator, sun rays fall vertically, right? And moving to the tropic of Cancer, at this place, tropic of Cancer, also sun rays fall vertically. Above the tropic of Cancer, above the tropic of Cancer here, the sun rays fall slantly in the sense, you know, somewhat bent it is. Instant, I'll show you. Instant, in this way, sun rays fall slantly. So there is bent in the sun rays. Whereas at equator, it falls straight. Instant, this is straight at equator. Instant, at equator, it is straight, and at poles, it is a slant. Instant. So what do we see here? This is the bent of the earth surface due to the spherical shape, right? As the earth is in spherical shape, we see that at every moment on earth's surface there is a curvature, that is bend. So what happens when there is a curvature? Here you will see that when there is a curvature, sun rays fall here vertically at a limited area, a smaller area, instead at equator. So this area receives high insolation, so it becomes much heated. Whereas when sun rays fall above the tropic of Cancer, there the area is larger. Look at this. At equator, this is the area, understand? And at above the tropic of Cancer, the area is larger, and the sun rays fall slantly, not directly. So insolation received at equator is higher, higher than the insolation received at what to call above the Tropic of Cancer is low. Understand? So that what do we see as insolation is low here, then here the temperature is low, whereas at equator the insolation is high here, so that the temperature also high at equator. In this way, we find the temperature is distributed unevenly. That means it is not heated throughout the earth in the same manner. So at equator the temperature is high, so it is what you call the place, what it is warmer. Understand? At equatorial region it is warmer. Understand? Then near the poles it is cold, and at equator it is warm. Understand? Because your insolation is high. Understand? So due to this we find the seasons are different. Understand? This is the point we discussed. Understand? Again, another point is there next, that is Earth's rotation on its axis. Second factor which affects the seasons, understand, that is daily rotation of the earth on its own axis. Understand? Dear students, here is a imaginary line connecting north and south. Understand? What is the line here? Imaginary line is there that connects north and south. Understand? Let me show you. Understand? This is a line here, north to south. This line we call axis. Understand? We call it axis. Understand? It is axis. This line, imaginary, actually there is no line. An imaginary line is there connecting what to call north and south. This we call axis. We call it axis. Understand? So earth is rotating, it's rotating from west to east. This is the east direction and it is the west. Okay, it's rotating from west to east. So when it rotates west to east, all the parts, means all the places on the earth surface move one time around its axis. This is axis, dear students. Okay, so your South African continent is there. It moves around this axis one time. India is there. India also moves around this axis one time. Then Asia is there. Asia also moves around this axis one time. In this way, all the parts, all the continents, that means all the parts in the sense, all the places on the earth's surface move around its axis one time. That what you call one day. We call it one day instead. That means to complete one rotation around the earth's axis, this axis. So earth starts completing one rotation around this axis. For that it takes 24 hours, dear students. It means that it takes one day. In other words, the earth takes 24 hours to rotate around its axis. Understand? How many hours? 24 hours. It is 12 hours a day, remaining 12 hours a night. Understand? Right? So 12 hours a day, 12 hours a night. Understand? It moves from west to east. I said to you, understand, look at this. You can identify here, there is a arrow mark showing here, that is from west to east. Understand, dear students, this is the west, this is the east. Understand, right? Towards your what you call left hand side it is west, and towards your right hand it is east. So earth rotates from west to east. Understand, west to east. Understand, so it moves from west to east. When it moves, what will happen there? Western portion, okay, this is dividing, axis is dividing earth into two parts. This is western portion towards the left hand side, and right hand side it is eastern portion, right? So when earth rotates from west to east, western portion of the earth comes to the east side. Eastern portion of the earth comes to the west side. Understand? So in this way, we see that the sun, the moon, and the stars appears to rise in the east and sets in the west. Daily morning we see that sun sun is rising in the east. Understand? And by evening this sun comes to west side. Okay, sun rises in the east, sun sets in the west. Understand? So how it is happening here? As earth rotating from west to east, we identify that sun is rising in the east. Understand? And sun sets at west. Understand, that is a illusion is created. Illusion means which is not actual thing, as the sun is constant at a place. Understand, as we are, that is as our earth rotates from west to east, for us it appears that sun rises in the east. Understand, and sun sets in the west. That is the illusion. Actually it is not happening. Understand? So what happens this one, right? So what is the change by the earth rotation, right? So when earth rotates, my dear student, you will see that here half of the portion, understand, I'll show you that half of the portion, this half portion, okay, half portion of the earth is phased towards the sun at a particular moment, right? This is so for example, sun is in the east. So that what happens here? This is the area, understand, completely, okay, is exposed to the sunlight, understand, right, at a particular time. So that all this area is what to call this total area, understand, half portion of the earth as it is exposed to the sun is littered, okay, is littered with sunlight. Understand, this portion is littered with sunlight. Understand, sunlight, understand, falls on this area. Understand, and opposite to this sunlit area, what I want to say, my dear students, it is what to call another one, that is this portion. Okay, this is the portion we see. Understand, it is completely dark as it is not exposed to the sunlight. Understand, right? It is a dark area. Understand, dark area as it is not exposed to the sunlight. Understand, so at a particular time, at one particular time, we see that one part of the earth, that is half of the earth, area is exposed to the sunlight, that we call it day. Understand? Another off portion of the earth is not exposed to the sunlight, that is called night. Understand? We call it night. Here 12 hours night will be there, another 12 hours we see the day by the earth rotation, dear students. Is it clear to all? So by the earth rotation we see that day and night, what is happening, day and night is taking place. Understand? Right? So just imagine that what happens if earth does not rotate. Understand? Let us think of it. Understand? Dear students, see that here, if earth is not rotating, just assume that, what will happen? Huh? We see that this area only exposed to the sunlight always, right? Understand? And opposite to this portion, what is that? Another portion, this one, uh, not exposed to the sunlight, this will be in dark. Understand? This is a dark, and this will be in light. Understand? Always off portion of the earth will be will expose it to half portion of the earth is exposed to the sunlight, another of this one not exposed to the sunlight. That means half portion which is exposed to the sunlight continuously receives heat, continuously receives heat. Understand? Which portion? The portion which is exposed to sunlight receives continuously heat and light. Understand? In all the days. So that what would happen here, this will become very heat. Understand? It means it becomes very hot. Understand? This becomes very hot. In the same manner, we'll see that another portion, this is completely in a dark, that is not lit with the sunlight. So this area will be cold. Understand? This will be what you call cold. Understand? So this becomes very cold, and another portion opposite to the cold side, that is hot. It's too hot in this region, and this is the region towards our right left hand side, that is too cold. So too hot and too cold, both these situations, both these what to call portions are not suitable for life. Understand? This is the reason. That means, what is the advantage of the earth rotation? The advantage of the earth rotation is that every part of the earth, understand, as it rotates, every part of the earth as it rotates will receive sunlight and heat. Understand? So that there will be change in the duration of the day and night. Understand? In the morning we will see that the sun rises in the east. Understand? That will be horizontal, right? When it comes to 12 o'clock, we see the sun is over our head. Understand? Here, over our head, this afternoon, right? Dear students, what do you see? Yeah? When we stand like this, then in the morning the sun appears straight to us. By 12 o'clock we see sun is over our head, right? By evening the sun comes towards west. That means there is a change in the daytime, right? Similarly, we see that there is a change in what to call a night time. So the duration of the day and the night will change by the earth's rotation. Is it clear to all? So what happens? with the daily rotation of the earth on its axis, right? It leads to the formation of the day and night. Understand? Seasons does not occur. What? The rotation, okay, rotation of the earth leads to forming day and night. Understand? So the effect of the earth's rotation is, that is, day and night occurs. This is a what another factor we discussed. Understand? And third is that the tilt of the axis to the earth rotation. Understand? The tilt of the earth rotation. Understand? So what is meant by the tilt of the axis, what to call of rotation, the tilt of the the tilt, understand that what you call the tilt of the axis of rotation when compared to the plane on which the earth moves. Understand? Dear students, just wait, we are coming to the point. It is what to call that the earth, when it is rotated, understand, when it rotates, it bends, right? That is called the tilt. Understand? Earth's tilt around the sun. This is the third factor. Understand? Tilt. Dear student, I'll show you that what it is. Understand? Earth's tilt. Understand? Look at here. I'm not getting the point. Just a minute. It is sharing the screen. Earth's uh, what to call tilt. Now it has come, right? So here the tilt in the sense tilt, okay, tilt, this is the tilt. Till, this word is there, tilt. Till in the sense bent. Understand? Have you observed here, dear students, in this rotation of the earth, have you seen the globe, right? How will be the globe? It is bent. Understand? Right? See the how is the axis here? The axis, where is axis, dear students? This is axis, right? So we think that axis should be straight like this, but it is tilted. Understand? Why it is tilted? Because earth is rotating. The earth revolves around the what you call sun while rotating around its axis. Understand? So here we see that it is called revolution. Okay, the tilt and the revolution both are there here. Understand? One is revolution. What is mean by revolution, dear students? It is the earth rotation and revolving around the sun, right? It means sun is here, understand? Then earth is here, okay? This earth revolves around the sun, understand? The rotation, that means the as earth moves around the sun, that is called revolution, okay? So while rotating and doing revolutions, we see that earth is tilted. Understand? That means it takes 365 days to complete one revolution. Understand? I'll take you to that figure, my dear students. Here it is there. Okay, look at this figure. Understand? This is the water revolution of the earth. Understand? Earth started moving around the sun. This is the sun, right? So it is moving around the sun. That is called revolution. Okay. To complete one revolution, Earth takes 365 days and 5 hours 56 minutes. Okay. It takes 365 days and just wait, it disconnected because signal loss. Understand? Wait, my dear students. There is signal loss. Huh? I'm connecting again, sharing the screen. It is what that? Okay. Now the comes the point. So it is 365 days. How many? Earth completes one revolution in 365 days and 5 hours 56 minutes. Understand? This is called 1 by 4th day. Understand? So there is one revolution by Earth will complete within to complete one revolution. It takes 365 days and 5 hours 56 minutes. Understand? That is the length of the year of the Earth. Understand? So this causes the water seasons. Understand? My dear students, have you observed this position, these diagrams, this is what to call the map, the figure, sorry, the figure. I'll show you that. Here, what is that? Here, this is June 21st, dear students. Huh? And this is what to call September 23rd, this one. Okay. And this is December 22nd, right? And coming to what to call this is March 21st. Understand? So why I'm showing this diagram, this figure to you know, you have to understand there is a lot of difference in the positions of the Earth in these dates instant, right? What do you see on June 21st? Sun rays fall directly at equator. On December 22nd, also, right? Sorry, what is I'm saying sunrise fall vertically on Tropic of Cancer. Tropic of Cancer, 23.5 degrees Tropic of Cancer, there on June 21st. And December 22nd, what do you see? Sunrise fall directly on Tropic of Capricorn. This is, dear students, instant. Look at this. This is the Tropic of Cancer, and here it is a Tropic of Cancer. Understand? That means the sun rays falling vertically on Earth position is changing. On June 21st, sun rays fall vertically on Tropic of Cancer, that is in the northern hemisphere, right? And December 22nd, sun rays fall vertically on Tropic of Capricorn, that is what you call southern hemisphere. Understand? Then coming to here, you see that on March 21st, sun rays fall directly on equator. March 21st, this is. And also we see that sun rays fall vertically, what to call, at equator on September 23rd also. On September 23rd, the sun rays fall vertically on equator. So what is this point here? Understand? Look at here, dear students. June 21st, sun rays fall vertically on Tropic of Capricorn, right? And December 22nd on Tropic of Cancer, the southern hemisphere. So it means that there is what to call change in the seasons by the tilt of the earth. Understand? Dear students, as earth revolving around the sun while rotating, it is tilted to form an angle to the orbital plane. Dear students, let me share that this is the path, the white color which is here, it is there, the way through, it is a way, it's a path. On this path, our earth is revolving around the sun. So this is called orbital plane. That is called the orbit of the earth. This is, understand? So earth rotates and revolves in a regular path around the sun, that is called orbit. Understand? Orbital plane. Understand? So while revolving around this orbit, around the sun in the orbit, what happens? This axis, imaginary line connecting the north and south of the earth, is bent, right? Always in all the positions. Have you observed here? In all the positions, here also axis is tilted on what you call March 21st, June 21st. Here also it is tilted. December 22nd, September 23rd. So in all these areas, understand, in all these positions, you see that axis is tilted. Understand? It means that there at every moment, when at every moment while earth rotation and revolution, we see that it is tilted to form an angle. Understand? What you know, this is, you know, that right angle 90 degrees angle will be there, right? If it is like this. Understand? My dear students, look at this. This is the what is surface, this is the what orbit I am showing. The line which I drawn, it is orbit. Understand? It is orbit. Okay, so here if it is another line straight down, then the angle here is 90 degrees instead, right? But what we see here, the earth axis is bented in this way, so there it forms certain angle, that is 66 end of angle it forms. Okay, to form 66 degrees, 66 degrees, 66.5 degrees. Okay, to form this angle, earth bends, that is earth bends 23 angle, 23 and off, 23.5 degrees angle. Instant, this is the what axis, dear students. Instant, this is axis. Okay, I am writing again. Okay, this is what you call a axis of the earth. Understand? So how much it is bended? 23.5 degrees. Understand? So that is the what bend. So what happens when it bends? uh, the portion of the earth receiving the sunlight changes. Understand? The portion of the earth receiving the sunlight changes. Understand? Look at this figure. Okay, some months we see that southern hemisphere faces directly to the sunlight. Okay, what is that here, dear students? Look at here. This is what you call September 23rd. What do you see? Southern hemisphere, this is the southern hemisphere that is facing towards the sun, so it is summer. Understand? What you call here, look at here that uh, this is a, we take June 21st. Understand? On June 21st, sunrise fall in northern hemisphere, this, so that is summer. As sunrise does not fall vertically, okay, sunrise falls slantly. Understand? That means vertically sunrays are reaching to the northern hemisphere on tropic of Cancer, so it is a summer in northern hemisphere. Sunrise does not fall vertically on tropic of Capricorn in the southern hemisphere, so it is winter. So seasons are different here, right? When we have summer, that is the northern hemisphere, when it gets a summer, and there will be winter in southern hemisphere, right? That is on June 21st. When it comes to December 22nd, dear students, what do you see? Sunrise fall vertically on tropic of Capricorn. Understand? So at that time there will be summer in southern hemisphere here, and winter in a northern hemisphere. Understand? Seasons are different. That means when we have summer, southern hemisphere people will get a winter. When we get winter, they get what? A summer. Understand? So why it is happening? There is opposition of the seasons. because the tilt of the earth and its revolution around the sun, right? When on June 21st, there this part, that is in northern hemisphere, will get sunlight and stand directly. But by December 22nd, you see that sunlight, uh, southern hemisphere gets sunlight directly. Understand? So here it is summer on December, and on June 21st, it is summer in the northern hemisphere because of the tilt. Understand? Right? And it is rotating. So when it is rotating, the portion of earth which is exposed to the sunlight also changes. Understand? So that there is a different thing. Understand? In other time, 1 minute only left, my dear students. In other time, we see that that is in March 21st. On March 21st, and what to call September 23rd. Okay, September 23rd. Yeah, dear students, understand? On September 23rd, sunrise fall vertically on equator. Understand? This is what to call on September 23rd and March 21st, sun rays fall vertically at equator. So those are the days, both northern hemisphere and southern hemisphere, okay, will get equal sunlight and sun. That means we see that at equator the sunlight and sun will be same. As the time completed, dear students, I am closing the